Okay, we're gonna look into some slightly more involved application of exponential function problems here. So we want to know for this one, what rate of interest to the nearest tenth of a percent compounded annually is needed for an investment of $200 to grow to $350 in 5 years? So we can set that up. As soon as we see the compound interest thing, we know that we're going to be using this equation. A is equal to P times 1 plus R divided by N to the NT power. Don't know what happened to the A there. That's a little weird. But for this problem, I know that A is equal to 350. That's what I want to get at the end. P is 200. And we know that we don't know R, right? That's what we want to know. We know that T is 5 and N is just 1. So when we set that up and we write it, we fill in what we know. 350 is equal to 200 divided times 1 plus R, which we don't know, to the fifth power, because T is just N is just 1. So uh, this is a little bit difficult here because now we have this we have R inside the base, and we don't really we haven't dealt with that yet. So we'll just go ahead and do some math. We'll divide both sides by 200, some basic algebra here. We get 7/4 equals 1 plus R to the fifth power. Okay, 7/4 equals 1 plus R to the fifth power. Now there's two different ways to deal with this same problem, uh, the same situation. One of them is to take the fifth root of both sides. Okay, so we can take the fifth root of both sides here, and what that's going to do for us effectively is get rid of these 5's. And so what it leaves us with is the fifth root of 7/4 is equal to 1 plus R. And then we want to solve for R, so R is equal to the fifth root of 7/4 minus 1. Okay, that is the same thing, by the way, as if I had 7/4 equals 1 plus R to the fifth power. If I just raised both sides to the 1/5 power, I raised both sides to the 1/5 power. Now powers to powers, we multiply powers, right? Our exponent rules here. So that would then leave us with, if we solve for R equals 7/4 to the 1/5 power minus 1. That's because rational exponents and nth roots are the same thing. So if we want to use a calculator to solve for this, we can. And we just, in a calculator, if you want to get an nth root, first you have to type the index, so it's fifth root, and then we're going to hit the math button. If we go down to 5, which is the little radical with the x index, and we type in 7/4 here, and then subtract 1, you will see that that is 11.8%. Okay, so 11.8% is the answer here. The same deal if you took 7/4, if you took 7 divided by 4 and raised it to the power of 1 divided by 5, that's also, it's the same math. Okay, there's another way to look at it that I wanted to show you, and that's by using Desmos. So if we let's get rid of all these things here. If we typed in y equals 7/4 and we typed in y equals 1 plus x to the fifth power, and we wanted to, ooh, that's not y, that's 7. Sorry, y. Now we can go and see where these graphs intersect, and the x coordinate will be the one that we are looking for. So 11.8%. So basically what we did there was we thought, okay, if I have this statement, right here, I could say y equals 7/4 and y equals 1 plus r to the fifth. And since I know they're equal, that means wherever these two intersect is the answer. So that's another way to kind of think of this problem. Let's look at another one real quick. Okay, so here we have a bacteria named Rhandotus spirillum is left to grow unabated with unlimited resources in an experiment. If the growth constant K of R spirillum is 0.42, how long in hours would it take for the number of bacteria to grow to 18.2 times larger than the original amount? Okay, so 18 so this one's a little different. This is it's a growth, so we're going to have something like Q equals Q naught times E to the KT power. Okay, where K is 0.42. Okay, T I don't know. That's what I'm looking for. Q naught. All I know about Q naught is that it's Q naught, right? It's Q naught. Q naught is Q naught. And Q is, we do know something about Q, it's 18.2 times the initial amount. Okay, so if we plug all this stuff in, we get 18.2 times Q naught equals Q naught times E to the 0.42 T, where T is the thing we need to know. Now you can see we can divide both sides by by Q naught, and what we're left with is just 18.2 equals E to the 0.42 T. Now, since we don't know what to do with that exponent yet, what we can do is what we did in the last one, where we say y equals 18.2 and y equals e to the 0.42t, or we just put t could be any variable, so we'll say it's x. And we're going to graph that, so let's go do that right now. Hopefully I can remember what they were. So y equals 18.2 and y equals, so e to the power of 0.42x. And so now what I want to do is see where these intersect, so I can zoom out here and see that they intersect at an x value of 6.9. And so 6.9 is the answer to this. I don't know, I don't remember what the question was saying about the units. So it wanted to know in hours. So the answer to this, by looking at the graph, was the 6.0. It's right there, 6.9 hours. And the only way we're able to do that is by using a graph. And so this is like kind of inconvenient because it'd be really nice if there was just a way we could say what it was. But obviously this is all just kind of a little convoluted. So here's the most basic possible version of that problem we just looked at. Or not the most basic possible, but a basic version of that problem. How would I go about solving this? There's a couple things you can do. We can't say, right? We can't say that this is that 3. If we had this, if we had common bases, by the exponent rules, we can say that x equals 1. But that's not what we have here, so that doesn't work. What we can do, though, is look at a table and say that's x, and that's 2 to the x. So we have 1, 2, 3. 2 to the first power is 2. 2 to the second power is 4. And 2 to the third power is 8. So this 3 right here is somewhere right between the 1 and the 2. So if I had to make a statement about x right now, I would say it's somewhere between 1 and 2. I could go back and look at a graph, which is not ideal. So I could say y equals 3, and I could say y equals 2 to the x power, and look at where they intersect, and it's right there at 1.585. So I could be like, oh, it's 1.585, but I had to graph that. That was the only way I could get there. And so where we're going with this is that there's a way that I can just say what x equals. I can say what x equals and not have to deal at all with decimals. I can say an exact answer. And you can see like x right here, x is an exponent. So I have x and I'm going to write in, it has to be an exponent here. And we're going to learn that that value is, what happened there? We're going to learn that the value there is it's called log base 2 of 3. And if that is very confusing to you, do not worry. You don't know what a logarithm is yet. But I hopefully it makes sense. And hopefully that shows you also that that and that are both exponents. So they're the same thing.